Okay, so the lesson is going to be implicit differentiation. It's going to be functions defined implicitly versus explicitly. What are you doing over there? Okay. Did I mention this is leading up to like the hardest thing in the entire? Okay. Thank you very much. So you're going to need to know what to do and when to use it, and I'll start writing out some objectives here in a minute. But the difference between an implicit function and an explicit function. So let's give you a form of an explicit function. So let's do 3x 2y is equal to 5. You don't have to copy this down if you don't want to. I'll tell you when. So basically, I can solve this as a function of y with respect to x explicitly. It's easily done. Subtract over 3x, divide by 2. So y is equal to 5 minus 3x over 2. It's explicitly defined in terms of x. Versus, let's see, we could have 3xy squared plus y cubed minus x to the 5th y squared minus 2x plus 5 equals 0. So that's going to be hard to solve for y, right? Very difficult. So we can use implicit differentiation for that. So we can take the derivative of y with respect to x, but what we're going to have to do is we're going to have to use the chain rule. So everything will be a function of f of u. So to find its derivative, we're going to do f prime of u times u prime. So y cubed is the outside function is the cubed function, and the inside function is the y. So we're going to do 3 times y, leave the inside alone, y squared. And then we're going to have to do the derivative of the inside, which will be the derivative of y with respect to x. So that means nothing to you probably right now, but hopefully as we do it, you will start hearing the same thing over and over again. I don't want to in any way insult your intelligence speaking slowly and loudly. So let's go ahead and get there. All right. So let's first of all, let's know when to use it, okay? And then understand what I wanted to tie it in before why we're doing the chain rule with it, because there'll be an inside function. So let's do a major objective is know when to use implicit. Okay, and I'm going to start being lazy with my language. I'm going to write differentiation right now, but when I say in this unit, when I say use implicit, derive it implicitly, then I'm going to be talking about that. So you would not need it in a situation like this if I was asked to take the derivative with respect to x of a function such as that. And the reason being, look at the variable you're defining and the derivative you're taking with respect to. These variables, you're taking the derivative with respect to x, with the differential in x. That's fine. Do not you do not need to use implicit differentiation. Do what you've always done. Because what's going to happen is everything is going to come together. Some terms you won't need to do anything different. Some terms are going to have products in them. Some terms are going to have product chains in them. Some terms are going to have product chain implicit all in that same term. So it's just going to all come together. You have to know what tool to use each time. So if I looked at this now, if I'm taking the derivative with respect to the differential in x of 3y squared plus 1, now it's time to use implicit. Okay, so it's as simple as this. When the variables agree, do as you always done. When the variables don't agree, use implicit. Okay, so that's when to use it. You don't even know what it is yet, but that's when you use it. So let's go ahead and learn what it is. So what we're going to do to learn what it is, I'm going to just differentiate an expression. Actually, it's an equation. I'm going to differentiate an equation implicitly, and then I'm going to mark steps along the way, and hopefully that'll help you. Okay, so let's see. So let's objective 2. Okay, differentiate implicitly. Okay, so let's see what are my instructions on my test or my assessment or my quiz or something. It'll be written like this: d dx So that's it. There you go. There's problem 1. So just go ahead and march through and do the derivative of every term as it's stated. And luckily for lecture purposes, I haven't put any product or additional chains beyond the implicit, right? So this one's nice and simple. So we'll be able to keep up. And then I'll give you a little bit more in your practice, and then we'll go from there. So now, I'm going to ask rhetorical questions. I'll just answer them myself, but I want you to answer them, ask yourself them in your head. So just differentiate. I said that and I forgot to write this. This is a step. I'm in a recipe right now. Differentiate both sides with respect to x. So to do that, now as I ask myself the question, sorry about that, I jumped ahead. So that would be on your notes. Differentiate both sides. So I'm going to go through every single term and differentiate as I need to. So let's go through the first term. I'm going to take the derivative of y cubed. The question I ask myself, do the variables agree or do they not agree? So let me look. Here's my denominator. That's what I'm differentiating with respect to, and that y. No, they don't agree. So I'm going to use implicit differentiation. So what I see there is the outside function is x cubed. The inside function is y. So I'm going to do the derivative of the outside. So the derivative of the outside is 3 squared. The inside is my y because it is not the x. I'm differentiating y with respect to x. So I differentiated the outside times the inside. Now the derivative of the inside is 1 times dy dx. So you've just, what that does is that tells you that is the differential of y with respect to x. So slow it down. So basically, take the derivative as normal any term that is not an x, or later on will be 2 in t or whatever. But in this case, x, take the derivative. Any term that's not x, follow it with a d something dx. So if I were taking the derivative of r, it would be dr dx. If I was taking the derivative of q, it'd be dq dx. So you just follow it all of the time. That's the chain. The derivative of the inside, the derivative of y is dy dx. So let's do it again and see if we can start establishing a pattern. So now move on to my next term. Do the derivative. Do it as I normally would. It's 2y to the power of 1. Did I take the derivative of something other than x? Yes. So I have to follow with dy dx. Do it again. Minus 5 times the derivative of y, so that's 1. Now, this is a commonly missed terms derivative, because the derivative of negative 5y is negative 5, or if it were x, it'd be negative 5. However, you can't forget that you took the derivative of y, so it has to be followed with a dy dx. Even though there isn't y left there in your answer, it has to be done. Now, we'll take the derivative of negative x squared, so it's negative 2x. Don't need to follow it with anything, because I took the derivative of an x term. Move on. The derivative of 4 is 0. 4 is not x, followed by a dy dx, but who cares? 0 times dy dx is just 0. Think about it. You're more than welcome to stop or ask me anything in it. Basically, every single time, take the derivative of every term, do it the way you normally do, follow with a dy dx. Okay. Now, after this, we're kind of done. You just need to isolate it, clean it up, and present it for dinner. And so I'm just all the rest is just algebra review. So I'm going to tell you what I'm going to do first, and then we'll do it. Basically, in algebra, if you want to find something and solve for it, what you do is you get every single term with that thing in it on one side and everything else away. And then you factor your GCF, and then you've had the GCF outside and everything else, and you just divide. And it's going to be the same thing every time. So let's just do what I just said. So get everything together with one side, get everything else away, factor GCF. So let's write that down. So the next thing to do, so we're going to put that in red. We're going to collect all terms with dy dx. On one side. Move everything else away. So let's see, I go through and I'm going to kind of identify where there is. So I'm looking at my first term, yeah, it's got a dy dx in it. Look at my next term, yeah, it's got a dy dx in it. Look at my third term, yes, it's got a dy dx. No, this one does not. And that one over there, if there were any dy dx's on the right side of the equal sign there, we would put them back on the left. But there isn't. So in this case, so we've got 3y squared dy dx plus 2y dy dx minus 5 dy dx equals a positive 2x. So let's look at every term. So this term is a product. It's got it's got 3 factors, but if we call one of the factors the constant, 3y squared and dy dx, they're every single term has a factor of dy dx in it. So let's remove that greatest common factor. Let's pull that out. Dy dx out of every term. That leaves me a 3y squared in my first term. That leaves me a 2y in my second term and a negative 5 in my third term. So now I'm trying to isolate this. So it's currently being multiplied by 3y squared plus 2y minus 5. So all I've got to do is divide or multiply by reciprocal. So we're saying, whoops, I should have said factoring. That was factoring, but you see it. And then so isolate, rewrite. So all I've got to do is divide both sides. So let me see, what's that going to look like? Dy dx is going to be equal to my 2x divided by 3y squared plus 2y minus 5. There is the rate of change of y with respect to x. But it has x's and y's in it. So you're going to have to know points on the equation to do that. So I'll just get something for you in a minute. All right, so I'm going to pause this because I don't even know how to pause it. I'm just going to stop it, and anyone that's not here, we're going to do this. Let's do one to get started. Let's do this. Let's do okay. And I'm going to let you get started, but for the people that aren't going to be able to ask me questions, that second term is a product. So it will require f prime g plus fg prime, right? And when you take the derivative of the part that is not the x, you have to use the chain rule in terms of implicit differentiation. Okay, so we'll come back and maybe I'll start another video or not. We'll see. We'll see how it goes. I'm trying to stop it. All right, so you start that. I'm going to stop this video as soon as I can.